the acceleration is not constant, but it can vary with time. So previous lecture, I talked about constant acceleration case. So the learning outcomes for this class is we'll understand the kinematic relations, acceleration, velocity through graphical means, and then we'll solve problems when the acceleration and the velocity changes with time using graphs. Okay. So graphical interpretation of A equals dv dt. Okay, so this is an expression we wrote last time. The rate of change of velocity is acceleration. Okay, so one way of interpreting dv dt is that it is the slope of the velocity time graph. One sec. Okay, this is fine. This is the slope of vt graph. So velocity time plot. So assume that's the velocity time plot. Then what this expression means is that if you want to find the acceleration at some point, then all you need to do is find the slope at that point. So this is the slope. This is the slope, or dv dt. Okay. So if you know the slope, you pretty much know the acceleration. Now a further thing we can do is we can integrate this equation. This should be equal to, so what I'm going to do is I'm going to integrate this equation here. So dv is a dt, and if I integrate that, what I have is let's say that I want to integrate the velocity from v1 to v2. Okay, then this integral on the left hand side is simply v2 minus v1, and the integral a dt is actually the area under the plot, right? This is the area under the acceleration time graph. So this is the expression we need, and I'll show you the graphical interpretation of that expression. So now I need to look at the acceleration time graph. So acceleration time graph, let's say that is a curve. What I'm interested in is the velocity between 2 points. So let's say that I know the velocity here. I want to find the velocity over there. This is known. Then what I can do is I can use this, the area under the acceleration time graph. This is the area. So this is integral a dt. Okay, between times t1 and t2. So I can put that here. Okay, so if you want to find, in this case, let's say if you want to find v2, v1 is known, then v2 would be v1 plus the shaded area. Right. So this is that area. So you don't need, I don't need to give you a expression for the acceleration or velocity. You can use the graphical approach to figure out various things. Okay. Is that clear? Okay. The second thing I wanted to talk about is so similar to the velocity time graph, there is a position time graph which gives you the velocity. So let's do that quickly. And this is very similar to the previous thing I just talked about, graphical interpretation of v equals ds dt. So v is ds dt, which is nothing but the slope of the st graph or the position time graph. Okay, let's try to interpret that. So this is very similar to the previous plot, except that now we are looking at the position time graph. So if that's a curve, then let me draw a different one so that you're not confused. So let's say it's like this. Then if you want to find the velocity at a particular point, say t1, then all you need to do is get the slope. This is v equals ds dt at time equals t1. Okay, and actually not more than that, tells you things more than that. If the slope in this case is it positive or negative? What's the slope? It's negative. So if it's negative, then the velocity is negative. So it also tells you that fact by looking at the plot. What if the graph was parallel to the x-axis? What's the velocity? It's zero, right? Because ds dt is zero. S doesn't change with time. Okay, so then we can also do another manipulation, which is we can integrate. That got erased. So this is v equals this, and so what I'm going to do is I'm going to rearrange the stuff here. ds is v dt, and I can integrate this between let's say s1 to s2. ds is s2 minus s1 equals v dt between time intervals t1 and t2. So this is nothing but the area under vt graph. So similar to the previous plot, I can now interpret this graphically in the following way. So I'm interested in the VT graph. So VT, and let's say this is the curve. I'm interested in the distance the particle moves from T1 to T2. I know where the particle is at time t equals T1. I want to find where it is after a time of T2. And so if this is S2, then S2 will be S1 plus area under the graph. Okay, so this is the area under the graph. This is area under the graph, and that's going to give you that. So if you know the area, then you can find the distance traveled. If you know the distance the particle was at time t equals T1. T1, T2. Is that clear? Okay, so what we'll do is next is I'll do a very basic question and then we'll move on to harder questions. Any questions so far? Okay, so I want you to solve this question right now. Okay, so this is the velocity time plot of a particle. So what I want you to do is I want you to use what I just told you sometime back to find the velocity, the acceleration at this point A and the acceleration at point B. Can you try to do that? What I would like you to do is first do it yourself and then check your answer with the person to your person to your right. The guy who's on the extreme right can talk with the person on the left. Why don't you try to figure out the acceleration at point A and B? Are you guys trying or you want to try? What's the acceleration? What's the formula for acceleration? Is dv dt. So here's the hint. Acceleration is dv dt. So all you got to do is find the slope of the velocity time graph at point A and point B. Now can you do that? Do the question, solve the question. So anybody got the answer for part A? So I heard somebody saying 1. So let's look at this. So the area, the acceleration is the rate of change of velocity in order to find, the rate of change of velocity, right? So if you want to find the slope, what you need to do is you need to find, you need actually 2 points. So you can use this point and this point to get the slope, or this point and that point to get the slope. So in this case, let's use this point and that point. So the slope is delta y, or the y ordinate, divided by delta x, or the x ordinate. So dy is the position of the coordinate of A is 1, so I'll write that here, minus the origin, so 0, so that is dy, and then dx is this minus this. You're going to take the same point, so it's 1 minus 0, so that is 1. So 1 is the right answer. So you always want to put the unit, so it's meters per second squared. Okay, so so now can you find the acceleration of point B? It's 0. Okay, let's see if that's what we get. So dy dx. Okay, so again you got to find 2 points. So let's, in this case I don't know anything about the point to the right of b, so I know the y-ordinate here, I know the y-ordinate of that, so that's going to be 2 minus 2 divided by 3 minus 2, right? Is that clear? So that is going to be 0. So if the unit is, if the answer is 0, you do not need to put units. That's the convention. Okay, is that clear? Okay, now can you find the distance covered? So assume that the particle starts at rest, okay, at the time t equals 0. Can you find the distance the particle moves from 0 to a? And then can you find the distance the particle moves from 0 all the way to b? So the hint is that what we wrote down earlier, we wrote down that S2 minus, sorry, S2 is S1 plus area under graph. Okay, so you could use this formula, area under the VT graph, right? So can you find, so you're given S1, you're given that S1 is 0, can you find S2? How do you find the area of a triangle and a rectangle? That's how you do it. So somebody got 1, okay? Anybody else got a different answer? I don't know the answer. It's half, okay? So somebody said 1.5, okay. So let's do this. So S at A is S at 0, right? I'm using the same formula, plus the area under the graph. So that's going to be, this is the area under the graph, right? So what's the area of a right angle triangle? It's half base divided by height. So the base is 0 to 1. So the base is 1 unit. So that's going to be half times base, which is 1, times the height. The height in this case of this triangle is the distance on the y-axis from A to the x-axis, so that's also 1, and so this is 0.5. But S of 0 is 0, right? So that's 0, because I told you that if the particle starts from rest. Okay, so now can you find the distance the particle moves from 0 all the way to B? How much? 4? Okay, somebody got 4. 4? Okay, couple of guys got 4. That doesn't mean it's the right answer. You can get, you guys, everybody's convinced it's 4. Okay, I didn't solve this. Let's try to get the distance covered till point B. So SB is S0 plus area under the plot. So the area under the plot is the area all the way from 0 to the point B. So in this case, I'm going to show the area. This is the area all the way till here. Okay, so this area consists of 2 simple shapes. There is so there is this rectangle and there is the triangle. Okay, so what I'm going to do is I'm going to use the formula for the area of a triangle and a rectangle to figure out this area. So S0 plus area of the triangle from 0 to time t equals 2 seconds. So that's going to be half base. The base is the x coordinate, so 0 to 2, so that's 2, times the height, which is 2. So the height is from here to here, and the base was from right here to there, plus the area of this rectangle here. So that's going to be, the formula for the area of a rectangle is base times height. So the base is 1 unit, so from 2 to 3, times the height, which is 2 units. Right? So S of 0 is 0, so this is going to come out to be 2 plus 2, which is 4. So the answer is 4 meters and 0.5 meters, because this is the meters per second versus time plot. Okay, so you got to know areas of triangle and rectangle. That's kind of basic. 2 more problems, and so this is the velocity time graph for a car. What you have to do is you got to find the total distance traveled, and then you got to draw the acceleration time graph. Now I forgot to add one thing here. I need to say that I think the particle in this case starts from rest. If you don't have that information, you can't solve this. Let me just check this. So I want you to solve this question yourself. Yeah. So what I need to put here is assume that the particle is at s equals 0 at time.
Stuck in another building, sorry.
Okay, so why don't you try to solve for the distance traveled? So you're going to find the distance the particle travels from all the way from 0 to 80 seconds. Okay, the hint is ds is S2 minus S1 is area under VT graph. Okay, so it boils down to finding the area under the velocity time graph. Okay, did anybody get the distance traveled? Great. Can you say it slowly? I couldn't hear you. 6 meters. Anybody else? 600 meters. Okay. Anybody got a different answer? Okay, so let's just solve this. So S1 is the position at, in this case, 0. So that's 0. And we need to find the area under the velocity time graph all the way from 0 seconds all the way to 80 seconds. So that is given by the area of this rectangle and then the area of this triangle. Okay, so S2 is the area under the VT graph, so that's going to be half. Well, let me get the area of the rectangle first. So the base of the rectangle has a width of 40 because time is 40 times the height of the graph, so that's going to be 10 plus the area under the triangle, that's going to be half the base, so that's going to be 80 minus 40, so that's 40 times the height, which is again 10. So this is 400 plus 200, so that's 600 meters. So that's the answer. Okay, so the next part. We got to find the acceleration time graph. Okay, so I gave you the velocity time plot. You need to find the acceleration. So the question is, how is the acceleration related to the velocity? Because you know the velocity time plot. So acceleration is the rate of change of velocity. And so we only want to see wherever the velocity changes. That's what is the most important point in order to show up on the acceleration plot. So what I'm going to do is first draw the x and y axis for the acceleration at, and then look at the formula dv dt and try to see how I can find dv dt from the top plot, this plot. Okay, so acceleration is dv dt. So what is dv dt over here? So what I'll do is basically I'll try to find dv dt for a bunch of points. This point, this point, this point, this point. So if I can find dv dt for all those points, then I can basically draw the acceleration time graph and I'll be done. Okay, so what's the acceleration here at this point? It's 0, right? Because the velocity is constant. When velocity is constant, so all the way right here, the velocity is constant. It doesn't change with time. So dv dt is 0. So I'm going to use a different color. Say, okay, so it's kind of 0 all the way till 40 seconds. So 40. Okay. After that, what I notice is that the velocity changes with time. Right? So acceleration is not equal to 0. So I need to find the exact value for the acceleration. So I can find the acceleration by taking the slope. The slope in this case is going to be what? So t equals, let's say somewhere in between. Here, it's constant slope. So acceleration at 60 is going to be, I can use any 2 points. I don't know what this position is, so I'm going to use this point here and this point down here. So the slope is dy dx. In this case, dy is the y and the dx is x. So I'm going to write this as dv dt so it's not confusing. So change in velocity. So the velocity is 80. My bad. The velocity at this point is 0, or at 80 seconds it's 0, minus the velocity at 40 seconds, so that's going to be 10, divided by the time, which is 80, minus 40. So that comes out to be negative 0.25. So the acceleration is negative at that point. So then all I need to do is draw that here. negative 0.25. This is 80. Let me move things a bit around. Okay. Okay, so this is 40 and this is 80. So it's the acceleration plot is the acceleration is 0 for 40 seconds, and then it switches to negative 0.25 all the way to 80 seconds. So that's the acceleration time plot. Okay, any questions on that? Okay, so this is the last question, and I'll let you go. Okay, so a jet car is traveling at a velocity of 10 meters per second. Okay, and after at that point, it is subjected to an acceleration profile which looks like this plot. You're going to find the maximum velocity of the car, and you're going to find this time here, t prime, and you're given that at t prime the velocity of the jet car is 0. So let's solve it one at a time. So we'll first solve for maximum velocity, sorry, and then second part. Okay, anybody solve for the maximum velocity? Okay, so anybody got it? No? So the hint is, if you've not started doing this, is if you're given the acceleration and you're told to find the velocity, then you want to think about the velocity acceleration relation, which is a equals dv dt. And so if you integrate a dt, then you'll get the velocity. So now the question is, you don't quite know where the velocity is going to hit a maximum. Okay, at least at first sight. It's not that you're told to find the velocity at a particular point, you're just told to find the maximum velocity. So the question is, where do you think that the velocity will hit a maximum value? Is it going to be here? It could be here. It could be anywhere, right? But if you look at the plot carefully, you see that the acceleration is constant for the first 15 seconds, and then the acceleration goes negative. So if the body is accelerating continuously with a positive value, then the velocity will hit the maximum value when it is accelerating, not when it's decelerating, right? If you let on the gas pedal and you accelerate, when you let it go, which is the case, which is down, which is from 15 to time t prime, it's decelerating. So the velocity is going to decrease, not increase. So it has to be that the velocity is maximum at this point, right at 15 seconds. So we need to find the velocity at 15 seconds. If this graph was more complicated, right, it was up and down, like the velocity was positive, negative, then you'll have to find the velocity at each of those acceleration maximum values and compare the values to see at what point the velocity is maximum. The brute force method to do this is to find the velocity at every single point and then make a table and then find the value at which it's a maximum. But we can use a judgment that the velocity is maximum when the acceleration is going to be maximum and stay on for the most time. So in this case, just by that fact, we're going to use that fact. So this is 1, V2 is V max, and that occurs at 15. So I'll say t equals 15 minus the velocity at any point. So it's going to be, let's say that the velocity is 0, so that's 10. So area under the AT graph. So this should be the area from 0 all the way to 15. This area. Okay. So that's going to be half base, sorry, not half base, but base times height, area of the rectangle. So that's going to be 15 for the x-axis and 6 for the y. And so that's going to be 90. And so V max is V at t equals 15 is 90 meters per second. Oh, plus 10. Good catch. 100 meters per second. Okay, so that's part 1. Okay, so the next question is, what is the time when the car comes to a stop? So you're given that at time t prime, which is in the plot, you got to find the time when the car comes to stop. So you're given that the car comes to stop, which means that if the car goes, it's going to go. So think about it this way: the car is accelerating for the first 15 seconds, okay, and then it's decelerating. Okay, so when it decelerates, it has to come some point. It has to come to rest. It keeps decelerating, and so you're going to find the time at which it comes to rest. So how will you do this problem? The answer is what?
No, so the acceleration is 0.
So how will you start? What's the formula you use?
Divide the velocity by 4.
Divide the velocity by 4. Why do you say that?
Because the area of the rectangle on top needs to match the area.
Right. So what she's saying is the area of this has to match the area of that, because it starts from with 0 distance. So that's one way to do it. So let's do it that way. So the area of the formula is dV is area under graph okay. So the area under graph for this part there's a catch to it. I don't think that will work because it starts at 10 meters per second. It doesn't start at 0 velocity. So at this point, the velocity is 10 meters per second. So if it was 0 meters per second, yeah, that would work. So I don't think that will work. What else can we do? We can just use the fact that we can use area under the graph, but we can we know the velocity at 15. And we know the velocity at t prime, which is 0, right? And that's going to be the area under the graph, this graph. So that's going to be base times height. So that's going to be 15 times t prime times the height, which is minus 4. Okay, so what's the velocity at time t equals 15? It's 100. I just found it in the previous step. So that's minus 100 equals 15 times t prime times minus 4. And if you do the math on that, t prime comes out to be, I think I get 40 seconds. So that's your time. Yeah, so that was a nice observation that if it starts with 0 velocity at here, then the areas should match up, but in this case the velocity is not 0 at time t equals 0, so you cannot use that method. But you can if the velocity was 0. So here's another way to do it, which is if you know the velocities at 2 points, then you can find the area under the plot to find the time. So that's it. So I'll see you guys. So Monday is a holiday, so I'll see you guys on Wednesday. The homework one is due on, I think it's on Monday, end of the day on Monday.